Assalamu alaikum warahmatullahi wabarakatuh. Thank you, YouTube. Thank you, all subscribers, supporters, and viewers of this channel. Are you still interested with the ISO 14001 version 2015? Um, Identification of environmental aspects and selecting which environmental impact is suitable for those respective environmental aspects, and how would you do the input output analysis for the identification of environmental aspects? We are here in this video talking about it. I have an example for you, a process called furnace repair. If you are able to recall my safety, health, and environment videos, this is one of those activities which I've covered. Before we go on, my Muslim brothers and sisters, please do not watch this video if you're in a mosque for the Friday prayers and also when you are attending religious lessons. Thank you very much. I love you for that. I wish you Jannatun Naim. Thank you very much. So, in environmental management system, there is a process, a chronology in the establishment of the environmental management system ISO 14001. Okay, and the most important process is to identify accurately all the environmental aspects which are involved in our organization by literally auditing each unit process, each process which is involved in our organization within the scope of the ISO 14001 certification. Okay, now I will show you now where in the chronology of the implementation of ISO 14001 this particular process of environmental aspects identification is situated. Here we go. So this is the summarized uh, version of the chronology in the ISO 14001 implementation endeavor. These are the major items or perhaps steps that we need to do in order to have a good environmental management system based on the requirements set by the standard itself. Okay, now we are here. When we are identifying environmental aspects, we are right here. This process, see that? Identification of environmental aspects. It has got to be accurate. We have to audit our entire organization, be it administration department, be it the warehouse, be it the maintenance activity, be it the store, be it all. It would include especially our activities where our processes are. All these involves environmental aspects. From the toilet inclusive, if you have a pollution control equipment like a dust collector, that is an activity. We have to identify environmental aspects from that process or equipment too. Or if you have a industrial effluent treatment plant treating wastewater coming from your processes, effluent, industrial effluent, that is also an activity that we have got to audit to determine all the environmental aspects involved in that process. So it is here. We are here now. As far as, and the way we do it, we use an old school mechanical engineering principle, which is the mass balance. But we're not going to do the mass balance per academics say that is no. We are using the concepts of mass balance. And then please remember, why do we have to identify environmental aspects in the first place? Because ISO 14001 version 2015 define environmental management as managing environmental aspects by fulfilling two compliance obligations and addressing here risk and opportunity. So this is an important thing that we got to do for each aspect. Well, from the activities, inclusive the activities that generate or involve all these environmental aspects, we need to look into risk and opportunity, environmental risk and environmental opportunity associated to it. So that is where we are right now. And after we have identified the environmental aspects, we got to evaluate to determine which environmental aspects should be given the highest priority. We are able to find aspects that is of highly importance. Highly important meaning it could be related to legal or compliance obligation in that manner, okay? Or it is difficult to control, okay? Can be controlled but difficult to control, or we have opportunity for that reason in ensuring that these environmental aspects would not lead to the occurrence of environmental impact. So what is environmental aspect? Environmental aspects are anything, matter, substance, equipment, building, machines, anything, intermediate products, waste inclusive, okay? If it's in the soil, nutrients, the soil, the trees, these are all environmental aspects if we are there, okay, in that scope. So once that is done, we have to assemble them here in what we call environmental aspects impact register. And this is what I have come up for you based on my own personal hands-on experience over the years, what I call the dashboard for our environmental management system. I'll show you the later part, okay? And once we have identified all our environmental aspects, we know what our company is dealing with in terms of environment. Having known that, we would then proceed into developing our environmental policy. Having known what kind of aspects that we are going or have to manage, known all those aspects and our activities and our gaps, then we develop our environmental policy. And from this register of environmental aspects where we have got the risk and opportunity as well, we start to design our environmental objectives. What do we want to achieve? What do we want to set? That probably it is also referred to as intended outcome under ISO 14001 version 2015. And from then, we have got to formulate, establish what to do. What do we want to achieve? How to do it? Who do it? When to do it? And most importantly, how much does it take? It could be budget, monetization, and also inclusive of perhaps man hour. Then we develop what we call formally as environmental management plan. Now, objectives and EMP and target, they are lumped into one phrase by ISO 14001 called planning actions to achieve. Remember the word to achieve, meaning this is not just document. This is something that is achievable, and we have got to commit in achieving this. That is why it has been changed to planning to achieve. This time it's got to be serious, and those are our intended outcome, whereby the ISO 14001 stipulated that the intended outcome could be our objective, our targets that we have set for the company, and those intended outcome must reflect some endeavor that we would want to, or we in fact are serious in uh, getting the environmental performance for our company to a higher level. How high? Subjective. The company decide what you could do, what is within your capacity, what you could afford to do. All right. And also, while doing that, the intended outcome must also include our commitment in compliance obligation. In fact, compliance obligations to the law of the government could be environmental law to start off with, municipal business permits, EIA, environmental impact assessment terms and conditions, licenses, permits, terms and conditions, approval for land, approval for building, including tenancy agreement or purchase of buildings, including contracts, purchase orders, agreements with vendors, suppliers, okay, contractors, subcontractors, transporters, or, logistics, and any other outsourced parties which is interested or working for us. All these are obligations, and we have got to ensure those obligations is being fulfilled either by our company or those parties, both ways. Okay. And also it has to reflect achievement of environmental objectives. So this is the idea of environmental management system ISO 14001 version 2015, and this is the picture, the entire chronology, and where we are discussing in this video is about environmental aspects. So I hope you have got a picture on the implementation of ISO 14001. Okay, so let's go into the next slide. And in this slide, I will show you how we identify environmental aspects using what is called input-output analysis. Here we are. All right, my fellow consultants, trainers, auditors, and especially our honorable colleagues, safety health officers, safety health managers, industrial hygienists, all these experts in safety health and also environment. We are going to share this, all right? And for those who are embarking or reviewing their environmental aspects, I believe this is going to be handy for you. Look, this is called the input-output analysis. Why do we do this? We need to identify all the environmental aspects from each unit process, each unit activity in our organization or company. One of the activity, for instance, for this particular company is the furnace. And we are not doing the picture I'm showing you is not the normal working situation. It's not a normal situation for this furnace. This is the abnormal situation for this particular furnace and for this particular company. Why abnormal? Because a scheduled maintenance is underway. I believe you know about situations for environmental aspects: normal, abnormal, and emergency. Normal is when everything is working in order as per designed, as per desired. The desired flow rate, the desired setting are all in operation. That is normal situation. And those environmental aspects involves are environmental aspects in normal situation. And then comes situations like this: a planned scheduled maintenance. This is an abnormality in environmental management system, a situation which is not normal, so it is abnormal. It is planned. It is forecasted. It is being what they call well, as I said, planned. It is predicted. It doesn't happen sudden without anybody expecting anything. So this is an expected situation, which is scheduled maintenance, and all the environmental aspects involved in these situations are called environmental aspects in abnormal situation. And this process is an abnormal situation for the company. Unlike in another scenario, perhaps, when this furnace is working, temperature is high, those metal ingots are melting at like 700 Celsius, the furnace is closed. Suddenly, the electrode explode or spark off or broke. That is in environmental management system an emergency situation. I hope you get it. All right. I believe you remember our friend here. I didn't get his name. He's an old chap, but a nice person. Has been doing this. Is a master of all this. I'm not sure whether he's still in this country or back to Europe. Anyway, now this is how we do input-output analysis. We have input. We got to do it manually. You can have your format, develop your own format, convenient for you to register all this in this simple format. So you don't have to be more complicated than this. Now we have got input in one hand and output in one hand. What is input? Anything that enter the process. What is output? Anything that leaves the process. Got it? All right. Now input aspect. Let's take a look at input aspect first. One example, the brick furnace. This brick furnace is a material, fresh, new, brand new brick furnace. It is an environmental aspect. Why? Because it interacts with the environment. Got it? Why it is an environmental aspect? Because it interacts with the environment. Now, how does it interact? In order to know how it interacts with the environment, we got to know which stream of its life cycle it comes from. Look, this is a fresh, brand new furnace, and it is an input aspect. Therefore, we shall look at its life cycle perspective from upstream. In other words, where does it come from? So this furnace bricks, okay, is made from special well, clay and plus some other materials, for example, even kaolin, and these are clay from certain parts of the world, and in order to get it, mining is involved. Of course, there is a heating, what you call process to manufacture this clay, this furnace, and it is extracted from the natural resources, extracted from the environment. Therefore, the more extraction for these materials, for the bricks, the clay, meaning more of these natural resources are being extracted out. What is left? The resources are getting less and less. Therefore, the immediate or more popular environmental impact due to the interactions in making the furnace brick is resource depletion. And while extracting the material, a substantial damage to the earth structure is involved. Okay, and it would damage geological structure. That is why furnace brick is an environmental aspect, because in the supply and in the formation of furnace bricks, there's a lot of interactions with the environment, which eventually the most upstream is resource depletion and geological damage. Okay, I hope that is clear. On the other hand, when the fresh brick is arrived here, the old brick, the used brick, the old furnace brick has got to be removed, and when that is being removed, we call it used furnace brick. Please give some adjective so that you are able to identify whether it is an input or output. Okay, so we call it used furnace bricks, signifying that it is an output, environmental aspects. So when it is an output, so now we know that used furnace bricks is an output, environmental aspects. Question is, why is it an environmental aspect? What would be the eventual environmental impact? To answer that, we got to look at the fact that since it is an output environmental aspect, we have to look through its life cycle perspective downstream. We got to look downstream. In other words, what happened to this used furnace brick after it has been dislodged or dismantled from this furnace? What happened? For this company, this is in Malaysia. For this company, this furnace brick is classified as scheduled waste, and therefore its disposal is a closed loop management, meaning scrutinized. So eventually what happened is that these used furnace bricks are being stored in a dedicated storage area, and each container has got to be labeled, complete label accordingly with the waste codes, etc. And it will be collected by a scheduled waste contractor via trucks, which eventually will be sent to a final disposal premise, which is, we call it here prescribed premise, which has a facility of incineration, stabilization, recovery, and secure landfill. And from my understanding, from what this company told us and from the documents that we have vet through, it was found that eventually this material will be sent to the secure landfill. And as you understand, a secure landfill, eventually this brick over time will be degraded. All right. will have most of its outer surface be what they call disintegrated due to the action of the various sorts of materials in the secure landfill, and eventually it produces leach, and therefore it will leach out, and secure landfill is not 100% secure because the earth is moving, is vibrating, and hopefully not, but from past records, we have seen that there are cracks at secure landfill, and eventually it will contaminate the soil or even pass down through the dosage zone and find themselves into aquifer and perhaps contaminate groundwater. That could be the eventual environmental impact, but I didn't write down there groundwater contamination because I'm not given the evidence. Okay, but I can't do it based on past incidents record elsewhere because this one goes to a specific place in this country where the reports are not quite disclosed. Got it? So it's enough that what we know to our best of knowledge is onto the soil, and that would definitely cause soil contamination in the secure landfill. So the environmental problem from this company is not solved. It is sent to another premise, transboundary, transborder, and it becomes a pollution state. It becomes pollution in another site, which is the secure landfill. So that is the input output analysis for this particular process. Okay, and it goes for the rest. Those are the rest are examples that I have given. Electrodes are made from oil and gas products. Okay. Personal protective equipment also made from oil and gas product, polyester, polypropylene, etc., etc. And the refractory mortar is also made from natural resources. These are all upstream interaction because they are input environmental aspects causing upstream environmental impacts, normally resource depletion and also geological damage. Same thing as use electrodes subsequently, you get it? Dirty PPE, but somehow this PPE, some of them are recycled, but most of it has been disposed. All right, and empty mortar containers. All right, cured spilled mortar noise. Look, this one, you leave it to me instead of sending it to this one and also this one, these two items, spilled mortar and used brick furnace. You know what we did? I've tried this. We grind them. We grind the cured mortar. Those are spillage. We grind the used brick, the used bricks. We grind, we hammer it down, we crack it, and then grind it into powder. And you know what? We mixed it with gaolin and one or two of other stuffs. We make two things. We can make another regenerated mortar, or we can make bricks. Coffee, anyone? I've got my Arabica over here. We made bricks. Why waste? But we have got to be. We are all obliged to governance, to government. So hopefully they open their eyes and look into all these possibilities. All right. That's input output analysis to guide you doing your identification of environmental aspects. This is what you do, okay, for every process in your company. Yes, it is tedious. Yes, it takes time. Yes, it is meticulous. But if I were to follow my standard, I would quantify all this. How much furnace brick per metric ton of product from this company? Then your CEO, your financial controller might be interested. If you want to display the environmental management system in business language, I would do that. how much used furnace brick disposal cost per metric ton of the product produced by this company. But I'm not going to show it here. It's going to be too delicate for you. I don't want to scare people who just want to get into this, but I made it simple. This is how you do it, the methodology. Okay, now let's take a look at the dashboard, shall we? I love dashboard. You know why I love dashboard? I love to know the vehicle that I'm driving or I am riding, how does it perform, you know? And I love the dashboard to have, if I'm riding a bike, at least RPM meter, speedometer. I need the fuel gauge. I don't need the gear number. Well, and engine temperature. I think that's about it. Basic. With that, I know the performance. But today's a bike. I am a biker. You've got what you call like the 5 blade, perhaps Panigale, and also maybe BMW 1000R, S1000RR, ZX10RR, Kawasaki. All these comes, but the Kawasaki dashboard is good. It's been kept simple, okay, but the rest are quite sophisticated. You've got the traction control, ABS. You've got, if you're riding a bike and you need ABS or traction, maybe you do, but I'm an old school. We're trained to learn to lean into an angle. We don't even do trail braking, we release our throttle and we brake hard, yes, enough to the speed, and we release throttle a bit and we start to lean and hold the throttle, and as we get into the corner we'll get a bit more grip by increasing the throttle, and that's it. I don't need all those electronic stuff, but I appreciate those technology. You carry on with it, but I'll keep my bike simple. But I need the dashboard. Why? Because in this dashboard, for the environmental management system ISO 14001, it gives me a clear idea what I am managing. Look, you have got all the activities here and processes. There you are. You have got the furnace repair activity. Got it? And what are all the aspects? These are just three. All right. When you do your own aspect identification, make sure you cover everything. This is just illustration for this particular video. So I just picked three. What are they? Use bricks, electrodes. These are input. Spilled motor. These are outputs. There you are. The impact should be relevant with the aspect. When the aspect is output, the impact must be showing downstream pollution. When the electrode is an input, it should show upstream environmental impact. And the spill motor is an output, it should show downstream environmental impact. Simple as that. And this is important. For me, look, I got risk and I got opportunity in my dashboard. So what do we do here? For each aspect, we talk about what are the risks associated to it. For instance, this one, use brick is a scheduled waste, and disposing the scheduled waste, we got to pay for it. Buying it, the company paid. Using it, yes, we pay for the process, electrical energy, etc. We are paying for it, and it becomes waste. We want to call it waste. An opportunity under environmental management is to convert it into renewed bricks. Unfortunately, in some countries, the law disallow this, or the agency of that particular environmental authority might not allow it and still classify it as hazardous waste. So we got to comply. At this point, if you do have a methodology to convert all this into renewed products, then there will be some hurdle. I've gone through this. There will be some hurdle despite the fact that you are fighting for environmental conservation. The environmental agency is upholding the law, and the law is always right. Although we can convince them that the products that we are going to produce from this conversion is safe. Hazardous waste is hazardous waste forever. That is the mindset that can be detrimental to environmental resource conservation, to environmental conscience of people like you and me. That's the challenge for most environmentalists and, in fact, ecologists. Okay, so we have got to beat the law, but do not beat the law. What we can do is we can apply. We need to go through the protocol, even though it's lengthy and painful, literally, but resilience is needed for environmental conservation. Okay, and also we've got problems here with the electrodes. The cost of electrodes is a yo-yo stuff, depending on the country, oil prices, etc. And what we can do is, from my discussion with these people, is all about setting, operational setting for the furnace with the correct setting, and of course with the correct type of electrode. There are varieties of electrodes. We've got to use a state-of-the-art, good electrode quality, and it lasts 2 or 3 times longer than some OEM stuff and costs just about 150% more. It's worth it. So we got to look into all this cost saving, okay? And the schedule risk management also is related to spill motor, also cost. Look, I would rather do on-site treatment to make our own second grade, well, I could say refractory motor. Why not? All right, we save costs in disposing, and we save the liability in disposal of hazardous waste, and we are protecting the environment by not filling up the secure landfill, and we got products that you can use, and there could be a niche market for it. Think about it. Okay, so we have seen the input-output analysis, how we identify environmental aspects by virtue of doing the input-output analysis. And we have seen where the input-output analysis is in the chronology of the entire implementation endeavor, ISO 14001 version 2015. And we have seen the input-output analysis, why the aspects is an aspect, the rationale is given, remember the upstream, downstream of its life cycle perspective. That is the same thing that we need to use in order to determine their respective associated or related environmental impact. And here I've shown you the dashboard. That's the best I could do for this video. I hope you're able to catch the ball. YouTube, thank you again. And thank you all subscribers, viewers and supporters of this channel. And as a Malay, I wish you semoga dikurniakan kesenangan, keselamatan, kesejahteraan, kebahagiaan, dan kejayaan kehidupan di dunia dan di akhirat. And I wish everybody, until we meet in the next video, inshallah, I wish everyone, whoever you are, wherever you are, whatever color, height, size you are, and whatever language you speak, and whatever faith have you, this wish. Assalamu alaikum wa rahmatullahi wa barakatuh.